So in this video I will take a cantilever beam. So find the reactions of a cantilever beam shown in figure. When we can say that a beam is cantilever, if it is fixed at one end, we can say that at point A it is fixed and at point C it is completely free. At point A it is fixed and at point C it is completely free. Then we can say the beam as a cantilever beam. There are two types of loads present on this beam. One is UDL and a point load. Then it is a statically determinate structure because at point A we have three reactions since it is a fixed end, and all the three reactions can be found using the three fundamental equilibrium equations. So this is called as the loading diagram. Below that I will write the free body diagram. So write once again the length of the beam as it is from A to C. Totally it is having the span of 4 meters. Okay, I will write the distances later once I will indicate the loading values. Now this is UDL. I will convert it into a point load. How it can be converted? It is just 10 into 2, that is nothing but 20 kilonewton, where it will act exactly at the center. Exactly at the center, 20 kilonewton, that is 1 meter from the left end and 1 meter from the right end from point B, that is point B, exactly at the center of the UDL. Then 10 kilonewton as it is, you write it because it is a point load. From point B it is acting at a distance of 2 meter. So the total span comes around 4 meter now. Then write the reaction lines. Since it is in fixed end at A, we have three reactions. One is vertical reaction at A, VA. One is the horizontal reaction. HA. Then there is a resisting movement. So three unknowns. And I have three equilibrium equations. Summation Fx, summation Fy, and summation M. How many unknowns are there? Three unknowns: VA, HA, MA. Three unknowns, three equations. So cantilever is a statically determinate beam. As I explained in the earlier videos also, for our portion we have only statically determinate beams. That means either the beam can be simple support, single overhanging, double overhanging, or cantilever beam. That is all for our syllabus now. Now I will apply the equilibrium conditions one by one. The first condition I will apply: summation Fx is equal to 0. What are all the forces acting in the horizontal direction? HA is the only force, and there is no force in the horizontal direction, so I'll write HA is equal to 0. The first unknown is found. Second condition, summation Fy is equal to 0. Vertical forces: VA upward positive -20 -30, VA -20 -10, okay, is equal to 0. Therefore VA comes around 30 kilonewton. Second condition, second unknown is found. Then I will take the moment, apply the third condition. Summation MA is equal to 0. I will take the moment at point A now. Please note this point. A as the moment center now. VA will not create any movement at A because it is passing through A. There is no lever arm. HA will not create any movement at A because there is no lever arm. But we have to consider this movement because this is a movement, not a force. Please have a note on this one. VA and HA are the forces, reaction forces. So these two forces should not be considered to calculate the moment at A because they are passing through A only. 20 we can consider, 10 also we can consider. Moment means force into perpendicular distance. Now if I take ma is equal to 0, what are all the, I will write the equation. Since it is in anti-clockwise direction, I will write minus ma plus 20 into 1 clockwise plus 10 into 4 is equal to 0. Then if you simplify, this value, you will get ma is equal to 60 kilonewton meter. This is the value we will get ma value. The third unknown is known now. First unknown, second and third unknown is known. So since we have two reactions at A, ma is the moment. So we can find the resultant at A. We have two reactions, Va and Ha. Therefore, Ra, the resultant, is equal to square root of Va square plus Ha square. So anyhow H is 0, therefore 30 square. So this and square root cancel. Ra is nothing but 30 kilonewton. So this completes the problem. Once again I will explain. Loading diagram, free body diagram, apply the equilibrium conditions, we will get the solution. Thank you.